Good morning and happy Wednesday. It's Wednesday. We're still talking about slope again. So today we're going to look at slope-intercept form, which is where you will see that slope that we talked about yesterday. So yesterday I taught you guys how to find slope from points. So if they've given you points, how can you plug it into a formula and figure it out? And that formula tells us basically how far apart 2 points are. So between these 2 points, you'll be moving up 5 and down 1. So that's how you're going to move to get from one point to the other. So how far apart are their y values and how far apart are their x values? So that's what this formula tells us, the difference in the y's and the difference in the runs, so that you know how far apart your points are and what your slope might be. It might be really steep, it might be not steep at all. And so we were able to find that from points, but usually in math, your linear functions, instead of them giving you points that you graph and then find the function, or find the slope, they'll give you the function, and you use this to make your graph and to get those points and to plot them. So I wanted to show you where slope goes in the formula and kind of what it all means together. So I know you've seen y equals mx plus b before. It is like the first function we're going to start talking about here soon. It's the easiest. It doesn't mean it is easy, but they only get more complicated from here. So in a linear function, the m is your slope, and you saw that yesterday when we were solving for slope. M was slope. It's always going to be right next to your x coordinate. These x and y coordinates, in your formula, they will always be x and y. So when you're writing your functions or you see a function, there's not going to be a number here and a number here. That would just be a lot of numbers. So you'll always have your y and your x there, and that lets you know that you're working with a function. Y equals, and then everything else. And as long as your x is here stuck beside a number, and it looks like this, you know that it's a linear function. This kind of gives it away. So your slope will always be here stuck beside the x, like a coefficient, and then you'll have plus b. Now, if your starting point, the b stands for your starting point on the graph. So it's like where it crosses that y-axis. It's your y-intercept. If your starting point, if your b is a negative point on the y-axis, it would be minus b, right? So it would be, mx minus 3 if you started at negative 3. So you just have to keep in mind this plus b could be a minus b, depending on where you start. So this b is your y-intercept. So it is going to be a point on the y-axis. It's your starting point. So anytime you have a linear function like this, I always work backwards. I start at the back where the b is, and that tells me where to put my first point, and then I move based on my slope. So if someone gave you this example, y equals 2x plus 1, when I look at this, I can say, okay, this tells me how to move. It tells me my slope is 2 over 1, so I'd rise 2, run 1. And then this 1 tells me where to start. So if we look over here, I started with a dot on 1 on the y-axis. So 0, 0 is dead center. I went up to 1 on the y-axis. And I moved up 2 over 1. And you can see I went up 2 over 1, and I put a dot. And then from this new dot, we do the same thing again. Up 2 over 1, and we put a new dot. And then you can connect them and see this is the line, these are the points, this is the function. And it all works together to tell you everything that it's telling you. So I can look at this and say, oh, this line should start at 1 and have a slope of 2. This line starts at 1 and has a slope of 2. This is this graph. They line up. Now, from yesterday, I could have given you the point 0, 1, and what is this? 1, 3. I could have said find the slope of 0, 1, and 1, 3. So I could have given you these 2 points. You could have found the slope, and then you could have plotted those points use the slope that you just found, made your line, and you could have made this equation from all of that. So there's different ways that this information can be given to you. They could give you points and you have to graph it and do the formula to find the slope and figure out, okay, in this graphed line, what's happening? What is my slope? Where does it cross the y-axis? And then you can write it like this, or they can give it to you like this and you have to create all of this. And so we'll get into all that more, but I just think it's really cool how it all ties together. So another example would be y equals -1/2 x plus 3. Okay, so this tells me my slope is -1/2, and that 3 is where I need to start on the y-axis. So over here, you'll see that I started at 3. 1, 2, 3, and I put a dot right there. Now, because this is -1/2, that does not mean -1 and -2, because we know two negatives would make a positive. That means that this negative symbol either goes up top, -1/2, or it goes down to the bottom number, 1/2. Only one of these numbers is negative, okay? Because if they were both negative, then there would be no negative at all. It would be a positive. So from here, and this is what I was telling y'all yesterday, it doesn't matter if you go negative first or positive and then negative. So it doesn't matter which number you want to give the negative to. You'll still end up on the same function line. So over here, I tell you, I either moved down 1 and to the right 2, which is positive direction on the x-axis. So I either gave that negative symbol to the 1 and went -1/2, or I gave the negative symbol down to the bottom. I gave it to the 2, and I made 1 positive, and I went up 1 and to the left 2, because the 2 is negative. So you can either do -1 +2 or +1 -2. It doesn't matter, because as you see, I still ended up on the same line, just at a different place. And then I connected those dots, and I found the function line that goes with this function. And it all makes sense. I can see I start at 3. I can see the slope and how we're moving. And that's wonderful. And the last example, this one is a bit, I guess, tougher. I made an error, so we'll put our finger over that in a second. But from the points, which is what we talked about yesterday, I want you to find what the equation would be. So from points, you always have to find your slope first, and that way you know what to do when you get over here to graph it. And then once you graph it and that line cuts through the y-axis, just find where it cuts through so that you know this y-intercept. So I put down here y equals blank x plus blank. This is where the slope will go and the y-intercept will go. And I have to solve for the slope and the y-intercept. So first I use these 2 points to find my slope using our slope formula. So I labeled them, and then I did y2 minus y1 over x2 minus x1, which is what we have right here. So from these 2 points, the slope I got was -6 over -3. And we know 2 negatives make a positive. So that just reduces down to 2. But I kept it over 1, over my imaginary 1, to help me see rise over run. Okay? So if this is my slope, I went over here and I plotted these 2 points. So I plotted 2, 2, which is up here. So I went over 2, up 2. And then I plotted -1, -4, which is right here. So I plotted these 2 numbers first. And then from those 2 numbers, I knew how to move. Because I don't know what to do with those 2 numbers. I mean, I could get a ruler and try really hard to make a perfectly straight line and then, count what my slope would be. But it's always more efficient if I just find my slope. I know how to move. So from here, now that I know what my slope is, I went down 2 over 1 and put a point right there. Then I did it again, down 2 over 1 and put a point right there. And then one more time, down 2 over 1 gets me to my -1, -4 point. So all these points are lining up because they all have the same slope. We're just moving the same way over and over. Disregard that little dot right there. I was off a little bit. So once I've got a couple points here, I just draw my line through them all. And now I can say, okay, the slope we solved for, that's wrong. is 2. Sorry. The slope we saw for up here was 2, so I can bring that down into my equation. I know it's 2x, but the y-intercept plus b, I didn't know what it was until I graphed it. And now that I graphed it, I can see that it cuts through at -2. So I'll put the -2 here. So the simplified version would be y equals 2x, 2x minus 2. This line matches up with this function. And we found all that out just from those 2 points. Figuring out how far apart they are, how you move between them, and where this line cuts through that y-axis. And that's everything we needed. So for today, I'm going to give you some practice where I've given you 2 points and I need you to find the slope. And then I'll give you some examples of equations, and I'm going to ask you what's the slope, what's the y-intercept. So make sure that you know which part is which and you can identify so that when we get into graphing, we have a good understanding of what the slope is, what the y-intercept is, and how we find the slope from our points. I will upload a picture of today's notes for you since I didn't yesterday. So thank you guys for watching that video yesterday and following along with me. Don't forget, as I continue to say and remind you, that you do have a test this Friday, so make sure you're going over your notes and you're really paying attention and doing your best. All right, bye guys.